Hello and welcome to Controllers Tech. This is the second video in the STM32 Ethernet series using the Mongoose library. In the previous video, we introduced the Mongoose library and demonstrated how to set up Ethernet functionality on STM32 microcontrollers. Today, we will focus on the Mongoose Wizard, a tool designed to simplify the creation of professional web interfaces without requiring advanced design or front-end development skills. Here's what we'll cover. How to use the Mongoose Wizard to create web interfaces. How to link interface elements to STM32 components for functional integration. Before diving into the wizard, let's briefly review the features and capabilities of the Mongoose library. Mongoose is a network library for C++. It provides event-driven non-blocking APIs for TCP, UDP, HTTP, WebSocket, MQTT, and other protocols. It is designed for connecting devices and bringing them online. On the market since 2004, used by a vast number of open-source and commercial products, it even runs on the International Space Station. Mongoose makes embedded network programming fast, robust, and easy. The Mongoose Wizard simplifies the creation of professional interfaces without requiring design or front-end expertise. It supports user authentication with multiple access levels, which can be enabled effortlessly via a single checkbox. Additionally, dashboards are kept up to date with a built-in device connection indicator on the toolbar. UI controls such as drop-downs, toggles, and inputs can be easily mapped to C structures by adjusting getter and setter functions. Conditional display functionality allows data exceeding predefined thresholds to be highlighted using alternative styles. Moreover, Mongoose provides seamless firmware update support for microcontrollers like STM32, ESP32, and others, requiring no additional configuration. Let's start this tutorial by creating the web interface first. Click on this button, Start Building Web UI. This is the UI I was testing previously. Let's create a new UI. We can integrate the UI into an existing project, but here I will create a new project. Now first select the directory where you want to store the project. I am creating a new folder for it. Now choose the target board. They have listed pretty much all the STM32 boards which have Ethernet functionality. In case you are using a custom board, just select any board from here, and I will explain how to integrate it at the end of this video. I am using the H745 Discovery board, so I will choose the same. Choose the build environment as Cube IDE. And we will not use the RTOS for now. Next we need to choose the dashboard we want. I am selecting the one with a single LED. Click Finish to complete the project setup. Right here we have our dashboard. On the left side, there is a sidebar, where we can add multiple pages. On each page, we can add multiple elements. The Page Content tab shows the hierarchy of the elements. The UI Element tab contains all the elements we can add to the UI. We have elements like blocks, inputs, display, and buttons. The REST API tab contains the API endpoints. The endpoints will be connected to the elements, which will then be used to call custom actions. You can control the color of the UI using the style sheet. We can also define custom CSS classes here. Info logs contain the logs, and the code tab contains the final code for the project. You can see it has a similar structure to how the cube generates it. Let's come back to the page elements, as we will add some more elements to this page. The H745 Discovery has two LEDs on board, so I am going to add one more LED control button. To do so, first I am adding a container inside the first container itself. Then I am adding a text, and a toggle button for the LED. Let's rename the LED1 to LED red, and the second text to LED green. Let me resize it, so that both the buttons look symmetrical. Alright, now we have some error in the second toggle button. If you check the info logs, you will see that the error is due to the invalid API endpoint. The endpoint for the first button is already defined in the REST API tab, but it is not defined for the second one. Here you can see the API name is set to LEDs, and it is of type data. This data field actually maps a web UI panel to a C structure. The first element of this structure is LED1, and it is a Boolean type variable. Let's change its name to LED red, and the type is still Boolean. The default value is set to false. Let's add one more element to this structure, LED green. It is also a Boolean type, and I am setting the default value of this variable to true. Now go back to the page elements, and click on the toggle button element. Here in the API variables, you can see all the variables we created in the REST API section. This button is associated with the red LED, so select the same API variable. Similarly, select the green LED API variable for the green LED button. You can see the button is in the on state. This is because I configured its default value to true. If I set this variable to false, the button will also be in the off state by default. Below the attributes you can see the generated code for this endpoint. This part will be generated in the glue header file, which will basically be a read-only file. We can modify the code in the glue source file, where we can connect these variables with the LED on the dev board. Alright, our LED panel is ready now. I am going to add one more container for the slider. We will use the slider to vary the PWM, hence controlling the brightness of a LED. We don't need all these elements, so let's delete them. Let's give this container a name, PWM value. The PWM value is going to vary between 0 to 255. Here we will add a slider. Now we need to create an endpoint for this slider too. Let's add a new API endpoint. I am naming it PWM, and this is also a data type, hence it will be a structure in C. Value will be an element of this structure, which is an integer type variable, with 42 as the default value. You can see the code generated for this endpoint as well. Now let's go back to the slider, and change its API variable to PWM value. You can see the default value has been set to the slider. I am going to add one last element here. Let's add a container first. I am adding a gauge, which will display the ADC value. Now let's create one more API endpoint for the gauge. Just like PWM value, this structure will be ADC value. Now set the correct API in the gauge setting. The transparent background does not look good, let's change the background color of the gauge. Alright, this looks fine. We want the gauge to update along with the ADC value. We can do it in two different ways. The first method uses the WebSocket to send frequent updates to specific elements on the UI. While the second method uses a timer to auto-refresh the entire UI. Since we want to only update specific elements on the UI, it is better to go with the WebSocket. To implement the WebSocket, first enable it on the settings page. Now open the REST API section, and name the API endpoint as WebSocket. The value will still remain the element of this WebSocket structure. Let's go back to the gauge, and set the correct API variable here. Once the WebSocket variable is set in the element, it will disappear from the REST API. Although to test the WebSocket, you can use this WebSocket message generator. Here we just need to enter the WebSocket element, along with the value we want to transmit. This is the structure of the WebSocket message, and we need to create something similar in our code to send WebSocket updates. One very important thing before we finish this design. We need to turn on the autosave of all the inputs or buttons we have added. If the autosave is off, you need to create a separate submit button to submit the changes made to the UI during the runtime. Autosave will automatically submit the changes. That is all we will design for now. We have two buttons to control the LEDs, one input as a slider to vary the PWM, and one display as a gauge to display the ADC value. Let's generate the project by clicking this Generate button. You can also save the wizard in a separate JSON file, which you can load later, or share to someone else. This is our project folder. We will load it in the Cube IDE, so let's open the IDE first. Now click on Import Projects, browse the project folder, and click Open. Alright, the project has been loaded in the Cube IDE, and here is the main file. Let's build this project once. There are no errors during the build. Here you can see a separate Mongoose folder, which contains all the Mongoose-related files. We have the Mongoose configuration file, the same as we created in the previous video. By default, Mongoose uses the DHCP, and you can get the IP address in the serial console. I have explained it in the previous video. Since I am directly connecting the Ethernet cable to the computer, I need to use a static IP instead. Let's uncomment this part. The default static IP is set to 192.168.0.10. Let's flash this project to the board, to check if everything is working fine. The project has been loaded to the board. Let's open the browser, and navigate to the defined IP address. You can see the web UI has been loaded here. The respective components on the board will not work as we have not connected them with the UI elements yet. But the UI is loading fine, and so we can proceed with our code in the IDE. Let's open the IOC file to edit the cube configuration. Let's open the board schematic to see the available pins. Here you can see the board has two LEDs, green and red. The green LED is connected to the pin PJ2, while the red one is connected to the pin PI13. Let's search for these pins, and set them as output. Here they are already configured as the output pins. Now go to the GPIO configuration. If you are using a dual-core board, make sure to assign the pins to the correct code. I am using the Ethernet on M7 core, hence I am assigning both pins to M7. Now we need to set the pins for PWM and ADC. I am connecting the SD Mode Plus, which comes along with the board. This is basically an extension for connecting various devices to the MCU. It has a PWM pin, which is connected to PA3. Let's search for this pin in the cube. This pin is connected to timer 2 channel 4, timer 5 channel 4, and timer 15 channel 2. Let's set it as the timer 2 channel 4 pin. Now we will configure the timer 2. Let's enable this timer, and set the clock source as the internal clock. Now enable the PWM generation on channel 4. We don't need to worry too much about the frequency. Timer 2 is connected to a PB1 bus, and by default it is running at 200 MHz. So I am using a prescaler of 2000 to bring the clock down to 100 kHz. The auto reload value is an important parameter. Just set it to the maximum PWM value, that is 100. At the value of 100, the duty will be 100%, and the brightness will be maximum. That's all for the timer. Now we will configure the ADC. The STMod Plus has an ADC pin, which is connected to PA4. Let's search for this pin in the cube. It is connected to ADC1 channel 18. Let's enable the ADC1 channel 18 in the single-ended mode. I am going to use the ADC in the polling mode, so I am leaving the configuration to default. There is some clock issue with the ADC. Let's set it to per clock, which is 64 MHz. I don't need a specific clock, as I am going to use a potentiometer here. Alright, that is all we need to configure. Click Save to generate the project. The Mongoose Glue source file is where we will connect the UI to our board. It has functions to read and write the LED data, and PWM data. Glue set LED function will write the LED data into the LED structure. Now we will read the first element of this structure, that is LED green. If the value of this element is 1, we will reset the pin PJ2. I am resetting the pin, because the pin PJ2 is connected to the negative terminal of the LED. So resetting the pin will turn the LED on, and setting it will turn it off. Otherwise, if the element has the value 0, we will set the pin to turn the LED off. Write a similar condition for the red LED as well, that is pin PI13. Next we need to deal with the PWM data. This data should be transferred to the capture compare register of the timer 2. To do this, we will create a new function, setPWM, whose parameter will be an integer type. Inside this function, we will simply set the value to the capture compare register 4 of the timer 2. Let's also create a function to read the ADC value. Inside this function we will read the ADC in polling mode. The steps are as usual: start the ADC, poll for the conversion to complete, read the data, and finally stop the ADC. We will use this map function to convert the 16-bit ADC value into a range from 0 to 100. The converted value will be stored in this val variable, which we will return at the end. Now go back to the glue source file. Include the main header file here. Now define the setPWM as an external function, as it is already defined in the main file. The glue setPem function reads the data from the slider and stores it in the PWM structure. We will simply call the setPWM function here, and pass the value of the PWM to the parameter of this function. This value is the element of the PWM structure, which is defined in the UI. We have finished integrating the LEDs, and the PWM with our board. Now comes the ADC. We have used the WebSocket for the ADC value, hence we need to create a WebSocket callback to transmit those values. Let's first start the timer 2 channel 4 in the PWM mode. You can find a WebSocket example in the dock itself. Here is the WebSocket callback, and this is the handler which calls this callback every 200 milliseconds. You can set this time according to the UI requirement. So let's define a WebSocket handler, which will call the callback every 200 milliseconds. Now we need to define the callback outside the main function. This is the WebSocket message structure. It should be in this format, with the key being the API attribute we created in the UI, and the value is the actual value we want to send. Instead of this format specifier here, we can input the key, which is value, as defined in the UI. And the actual value is an integer variable, which is returned by the readADC function. That is it. Let's build and flash the project to the board. Now open the browser again, and navigate to the IP address. You can see the discovery board on the right bottom corner. I am turning the red LED on. The red LED on the board is turned on. The green LED is also turned on. Now the red LED has turned off. The green LED is also turned off now. The LEDs are responding well with the UI. Let's try varying the PWM. You can see the brightness of the green LED connected externally. When the PWM value is 0, the LED is turned off. Now the brightness of the LED increases with the increase in the PWM value. At 100, the brightness is maximum. So the slider's input is working fine as well. Let's check the ADC now. Here I am rotating the potentiometer, and you can see the gauge value is changing accordingly. The potentiometer has reached the end, and the gauge also shows a value of 100 here. When rotated in the opposite direction, the gauge's value also shows the reduction. All the UI elements have been linked with different components on the dev board, and they all are working fine. Before we finish this video, let's explore one more interesting feature of this web UI, the login authentication. You can enable it in the settings page. It will basically lock the UI until the correct login credentials are provided. The login credentials are stored in the glue source file itself. We can modify the credentials as per our wish. It also supports various privileged levels based on the credentials, where the higher levels are more privileged than the lower. For example, the user has an access level of 3, while the admin has the access level of 7. Now we have edited the UI. If we simply generate the project again, it will overwrite the changes we made in our project. To prevent it, we can choose the option to integrate into an existing project. Even after this option is selected, the glue source file will be overwritten. So let's copy the changes we made in this glue source file. Now click to generate the code again. You can see a new glue file has been generated, and it contains the login authentication code. Although our modified data has been overwritten, so we will paste it here. Let's modify these login credentials. I am leaving the username to admin, and setting the password to password. Let's build the project once. We have some errors here regarding the GPIO pins. I forgot to include the main header file, so let's include it now. Alright, all the errors are gone, so let's flash the project to the board again. Let's refresh this page. Now we have the login authentication page being displayed. Let's enter the credentials that we stored in the glue source file. Alright, we have entered the UI successfully. Everything is working fine here. After the work is done, we can log out from the UI page, and it will go back to the authentication page again. So the login authentication page works fine as well. Also, we saw how we can edit the UI without needing to generate the entire project again. We generated the project from the wizard itself. But let's say that you want to implement the wizard on a custom board, which is not listed in the wizard. In that case, you must first go through the first video of this series, and implement the Mongoose library. Here I am importing the project created in the first video. This project had no relation to the wizard, we simply implemented the Mongoose library by copying the Mongoose source and header files. Let's delete those files first. Delete the Mongoose source and header files, along with the configuration file as well. In the main file, delete the run mongoose function, and the event handler we created in the previous project. Leave the rest of these functions here. I mentioned in the beginning that you can simply select any random board in the wizard, and create a project for it. Open the project folder generated by the Mongoose Wizard. Copy the Mongoose folder from this generated project, and paste it in your project. I am copying it inside the drivers folder. We only need the Mongoose folder generated in the project, and this folder is mostly independent of the board architecture. I said mostly, because the board architecture is only defined in the Mongoose configuration file. So you should use the same configuration file that you created in the previous project. Now open the project properties, go to C++ Build, Settings. Under the GCC compiler, select Include Path. Here we will add the path to the Mongoose folder we just copied. Click Apply and close this window. Let's build the project to check for errors. Alright, there are no errors so far. Include the Mongoose glue header file here. And call the function run mongoose inside the main function. Let's build the project now. There is an error due to the setPWM function. This function is actually defined as an external function in the Mongoose glue source file, but I haven't defined it in the main file. Let me remove all the reference of this function from the glue file. I am only testing if the wizard runs fine, although I am not connecting the UI elements to the board components. The project builds fine now, let's flash it to the board. Alright, let's refresh this page again. We got the authenticator page. Let's input the credentials. The web UI is loading fine. This means we can use the UI on any STM32 based dev board, irrespective of if it is defined in the wizard configuration or not. We just need to copy the generated Mongoose folder in our project, and use the correct configuration in the Mongoose config file. The Mongoose Wizard offers a lot more features. It supports MQTT client, SNTP client, Modbus TCP server, etc. We will explore these features in future videos. That is it for the video. I hope you understood how to use the wizard to create a web UI, and how to connect various elements of the UI to our dev board. We will see some applications based on this library in the next videos of this series. You can download the project from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.